Hey, hi everybody. Here's question 133 from chapter 3. In this case, we're given a female hormone, estradiol, and we are given a mass percent composition with all the elements present and the molar mass of the whole thing, and we're asked for the molecular formula. So in this case, we can get what we can do is we can get the moles of everything with the mass percent composition. We're going to use that to build our empirical formula, and then we're going to solve for whatever coefficient we need to multiply that by to make it equal to the formula weight that we're given. And we'll tackle that step by step. Okay, so from the values given, we know that in 100 grams of this hormone, it is made up of 79.37 grams of carbon and what is it, 8.88 grams of hydrogen, and the rest in oxygen, 11.75 grams of oxygen. All right, so we need moles of all these things to get our empirical formula. So moles of carbon, right? Mass over formula weight, right? You guys are experts at this, I'm sure. That gives us 6.0. Oops, excuse me, that is not right. 6.60866. Okay, moles of hydrogen, right? 8.88 over 1.008 grams per mole gives us 8.80952. Oh, goodness. Sorry, I don't know what happened there. 952. Okay, last, oxygen. We had 11.75 grams over about 16 grams per mole. And that gives us 0.734375. Okay, so when you're doing empirical formulas, you divide all your molar values by the amount of moles that's the smallest, which in this case is oxygen, right? So we need to divide this by the moles of oxygen, by moles of oxygen, by moles of oxygen. And that's how we're going to get our empirical formula. Okay, so let's make that happen. So empirical formula then is going to be blah, 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 blah. Well, it looks like I did. It looks like I just did all this and didn't write my values down. So let's just calculate this now. 866 divided by oxygen 75. I get about 9 for carbon. Okay, so C9. Hopefully this all works out now, or this is going to be super embarrassing. 0.952 divided by 0.734375. Okay, that's hydrogen over oxygen. Okay, that gives me 12. H12. Okay, and then oxygen over oxygen is 0. Or is 1, sorry, excuse me. Okay, and we have to calculate a formula weight of this thing. Right, so the formula weight of this is like 9 times the formula weight of carbon. That's 9 times 12.01. Okay, so that's, I'm just gonna write these as I calculate them. 108.09 plus 12 times 1.008. Okay, so that's 12.096. 6 plus 16 for oxygen. Okay, that gives us a formula weight for the empirical formula of 136 and change, 0.186. Right, so what we've got to do is we've got to find whatever we've got to multiply this by to get the formula weight. The formula weight is given in the question, so I'm just going to section myself off an area here, and we're going to do this calculation. Okay, so you can write it like this, right? So your how do I put this? Okay, your molecular formula is equal to some coefficient times your empirical formula. Right, so since we have the value for the molecular in the question, we just calculated the one for the empirical. We can solve for this thing with a simple division. So we're going to divide what's given, which was 272.37. We know that's the formula weight for the estradiol. We are going to divide it by the 136.186. You could probably do this thing in your head. This is going to give us 2. So to write the formula weight, like the molecular formula, we've got to multiply this whole thing by 2. Right? So molecular formula equals 2 times C9H12O. Right? Means that our molecular formula is equal to C18H24 O2. And there's your molecular formula.